Today I want to talk about some low-cost automation and how you can eliminate some batteries in your system. I just got this little timer. I was at a garage sale and it was only a quarter, and they probably think they snookered me because it didn't work. But this is a nice little addition to my shed. It's front and center, so I have a clock finally that I can look at without straining myself. And timers like this are very helpful. Suppose you had a water pump and you really only want it to pump in the middle of the day, so you're not draining down your batteries and you're sure everything will be okay towards the evening. You can set the turn on, turn off with this, and this is one I've converted to 12 volts, and it's actually a 24 volt timer internally, and it was designed to run on 110 volts, so it's got regular outlets here. But this is what I use. I have another one that I use for something else, and a little warning: if you buy these somewhere without instructions, this one is extremely complex. It's Chinese instructions, and even with a lot of thought, this took a lot of figuring out how to get it set up right. But this one's quite simple. One button sets the time, one sets the on, one sets the off, hours and minutes. And so let's go into what this kind of looks like. Internally, you have the control board that does all the clocking and everything. And down inside is just the relay and the power supply. And I'm going to talk about the modifications to that. So typically, you come in with your hot, which is 120 volts. It has this drop-in capacitor, and this goes into a full wave rectifier. Now, normally these things are just half wave, so there'll be just two diodes. This is a little unusual. So the relay was 24 volts, so I knew that the design was supposed to be 24 volts for the whole system, so I had to make some changes. Anyways, to get it down to DC, I jumpered out this capacitor. So 12 volts comes in through this 100 ohm resistor and through a diode. And what I have to do is, I don't want the whole thing floating. I'm tying the other end to ground, or common as the neutral is. So it's very simply hot and neutral. And then there were two 51 ohm resistors. I shorted one of those out. I could have shorted them both out or none of them out. The 100 ohm was probably sufficient, but I decided to just short one of them out. These were surface mount devices, and you'll see 510 on them. And you'd think first that's 520 ohms, but it's 5-1 with 1-0 after it, with no zeros after it because it's a 0. And so they're both 51 ohms. And then it went into a 24 volt center. Now the clock itself is just one of these 1.2 volt, 1.5 volt, and normally you find these and they're running off a little button battery. Now this one actually had a NiCad in it, and it had a little resistor emitting the charge current. This was shorted. That's the reason this thing wouldn't work anymore. So I just removed it. Now because I was supposed to be 24 volts and it dropped down to 12, this was a 4.7K resistor, and I just bridged another 4.7K resistor across it to get more current so you have enough drive. And there'll be a single transistor to operate the relay. I broke the connection to that because I want to go to the output with an open collector, because I have an external 12 volt relay that I'm going to operate. I had this little relay here, and this turns on and off. I got all this instrumentation, and there's no reason to run it at night, so this timer I got set up for basically 7:30 in the morning till 7 o'clock at night. I may change those times as the season goes on, but there's no reason to put current through this. And I put a little resistor, it's 150 ohms here, just in case I touch the wire to 12 volts and it's on, we don't burn out the transistor. But these are fairly simple, and if you can put one of these up at a garage sale for a quarter or 50 cents, it's worth playing around with these little timers, because they can just be really handy. So like I said, this battery was dead, just pulled it out and ran the collector over to the hot. So I come right out this plug, and you follow it up here, and it turns on that relay. Now, a lot of you will have little temperature gauges or things like that, and they run on these button cells, and it's very easy to run them off your battery instead. It's all these little cells are a pain in the ass. You don't never have the right one, they corrode up. So generally what you can do is a regular silicon diode is somewhere between 0.6 volts and 0.75 volts, and you can put two of those in series. This bottom here is the band side, and you can make something that's around 1.5 volts with it. Now some diodes are Schottkys, and they can be down to 0.27 or up as much as a little over a half volt. And so you really need to put the diodes together, see what you get for the voltage on them, and adjust up. I mean, you could do it with three Schottky diodes here maybe. And another interesting thing is LEDs aren't such a bad zener. A standard red LED is 1.7 volts. LEDs used to be common, and now there's a variety of them which are made in different processes, and there'll be different voltages. But two LEDs in series would give you 3.4 volts, which would be a nice little lithium battery replacement. So that's the tip for today, is that you can run a lot of your thermostats and other temperature controllers off your 12 volt system, and never have to fool around with those batteries. So thanks for watching, and catch you again.